Two laws, if we understand them and master them, we'll understand a lot about electrical engineering. We'll know how a heater works and why companies transmit electricity at high voltage while we in our homes need low voltage. These two laws are Ohm's law, which calculates the current for us using voltage and resistance, I equals V divided by R. And the electrical power law, which says P power, electrical power, equals V times I, voltage times current. Let's draw a simple electrical circuit. We have here a 5-volt battery and here a 3 ohm resistor. To find the current that passes here, we use Ohm's law, voltage divided by resistance, 5 divided by 3 amperes. That's the current passing here through the resistor. We use the power law to find the power consumed by this resistor, which equals V times I, which is 5 times 5 over 3, equals 25 over 3 watts. The passage of current through any resistor will generate heat for us. The resulting thermal energy will equal the power times the time during which we run this current, or the time during which the current passed through this resistor. So if we call the thermal energy E, for example, then E will equal P times T of as P, which is the power, and T, which is the time during which the current passed through this resistor. And the higher the resistance value here, the more heat is produced. This is the principle behind manufacturing heating devices. We pass a high current through a very high resistance and we get tremendous heat. Now let's move to electricity companies. When they deliver electricity over long distances, these electrical wires also have resistance, and when current passes through them, we'll get heat. But this heat is undesirable. In the case of the heater device, the goal was to produce heat. It's the final product that we want. But in transmission wires, this heat wastes the energy that we want to deliver to homes. So we want to reduce the heat here as much as possible. The obvious solutions in front of us are two solutions. The first solution is to reduce the resistance of the wires, and we can reduce it by increasing the width of the wire. Indeed, this solution is suitable for the heater because the wire is very short. But for electricity companies, we're talking about kilometers of wires. So it would be very expensive to widen the electrical conductors. The second solution used is to raise the voltage and reduce the electrical current, because the lower the electrical current, the less heat produced in the resistance of these wires, and therefore the power and wasted energy decrease. That's why we see the voltage is very high when it comes out from the electricity companies in kilovolts. Then, when it approaches homes, we use transformers that reduce this voltage to the values used in homes.